Welcome to this session on computational thinking for problem solving. I'm Dr. Shahan Perra from the Department of Computer Science and Engineering, University of Morocco. At the end of this session, you will be able to see what is computational thinking, why we need computational thinking, and how we can solve problems using computational thinking. This session is the first session in a series of sessions that are part of a course in Python Basics that is designed to help you to learn and get started on programming in Python. Once you get started on Python, you can also take other courses that we offer specifically designed for you, so that if you complete all the courses successfully, you will be able to become a software developer that has sufficient knowledge and skills to get started on a career as an entry-level software developer. We use a standard color coding mechanism throughout these slides to help you absorb the content that we have on these slides. So we will be using red color to indicate the very important points, and we will be using blue to indicate points that are important but may not be as important as the ones that are given in red. We will be using green for terminology and purple for other content that are slightly off topic but may be important to know. The basic outline of the session, we will cover computational thinking and a little bit about computer systems, including the history of computing. Sri Lanka is considered currently as one of the top destinations in the world to visit. Let's assume that you want to go on a trip to Sigiriya. Sigiriya is a very interesting place to visit, as it is an ancient rock fortress built by a Sri Lankan king. For some, planning a trip would be an enjoyable experience, but let's assume that it is a problem. Thinking about how do you go, when do you go, at what time do you leave, with whom do you go, what do you eat, how do you find the money, right? So we need to solve all those problems in order to go on this trip. Let's see how we can use computational thinking to solve this problem. You may be already using computational thinking to solve the day-to-day problems that you come across, but you may not be realizing it. Right, so let's look at what is computational thinking. So what is computational thinking? It can be used to solve problems. The basic problem-solving concepts and ideas come from computer science. If you can use computational thinking to solve a problem, you can also use computers to give the solution to the problem. At the moment, we have so many problems around the world. If you can at least solve a few of those problems, that would be great. Remember, computational thinking is not computer programming. In this course, you will be actually learning computer programming. You will learn the basics of Python programming. We can use computational thinking to solve a problem and then write the solution using a computer programming language like Python, and get the computer to solve the problem that we wanted solved originally. Today we use computers to solve a lot of our problems in engineering, medicine, agriculture, social sciences, military. You name any area, there would be a solution given by a computer or a computing device. That is why there's a huge demand for software developers or software engineers, people who can think using the computational thinking approach and solve these problems that are out there using computers. We also like to see those who are following these courses and completing it successfully become productive citizens of the world by solving some of these problems. We can also solve the problem of going to Sigiriya using computational thinking. There are 4 parts to computational thinking. We will look at each one of them separately with our example of solving the problem of going to Sigiriya. Once you look at the example, you will understand these very clearly. But for now, let's look at what they are very briefly. First one is decomposition. That is to break a bigger problem into smaller parts. We can solve the smaller problems or smaller parts of the bigger problem rather than getting stuck on solving the bigger problem. That is what we do by decomposition. Once we find the solutions for the smaller parts, we can put those solutions together and solve the bigger problem that we were faced with originally. Second one is pattern recognition. In this, we try to see things that are common to multiple similar problems or similar problems, so that we can reuse the solution or a solution that we have used for one of these similar problems. By solving one of the similar problems, or by using a solution given to a similar problem, we are able to solve multiple problems by using pattern recognition. Third one is abstraction. In this, we try to focus or look at the important things of the problem, or the details that matter to solve the problem, and ignore the other things that are around it. Sometimes we get distracted by looking at the bigger problem, or by looking at all the details of the problem. Sometimes it's only a few things that we need to concentrate on solving the problem. In that sense, what we could do is we can look at an abstraction of the problem and try to solve that problem by looking at the abstraction of the problem. Fourth, we have algorithm design. In this, we come out with step-by-step instructions to solve a problem, so that we can use the steps to solve this problem later, or else we can ask somebody else to solve this problem. And in computer programming, we do that. We come up with step-by-step instructions on how to solve a problem. So fourth part of computational thinking is to come up with step-by-step instructions or algorithm design to solve problems. Decomposition allows us to break a problem into smaller parts so that we can solve the smaller parts separately and combine the solutions to solve the bigger problem. This is something that we do to solve a lot of our problems. For example, in our trip to Sigiriya, if we want to break the things that we need to solve into multiple parts and then think about those parts separately, that would make it easier for us to solve the problem rather than trying to think about the entire trip at once. In our example, rather than trying to think about what we are going to do for the entire day, why not break it up? What are we going to do in the morning? What are we going to do in the afternoon? What are we going to do in the evening? Or else maybe what we could do is we could break it into the first 50 kilometers, the second 70 kilometers, and the remaining 62 kilometers by breaking the distance of the trip into 3 parts, and then consider solving the things that you want to do separately. Also, we can break it into subparts of what food we want to eat, and maybe ask the girls to solve that problem. Or what sites do we need to visit? We can ask another person to solve that problem. Or what transport mode should we use? Right? So that can be a separate part of the bigger problem, and we can ask somebody else to solve that problem. So breaking a bigger problem into smaller parts for the purpose of solving the problem is decomposition. Once we complete solving the individual parts, we have the entire solution for the entire problem. In pattern recognition, we try to see if we can find similar patterns in problems so that we can reuse the solution for a similar problem that we solved earlier. By using a solution that we have used earlier for a similar problem will help us to solve the problem much faster and efficiently. So to solve the problem of where to visit in our trip to Sigiriya, what we could do is we could check and see, did we go to Sigiriya earlier, and what are the places that we visited earlier? Or else we can ask a person who has been to Sigiriya. Rather than looking at all the interesting sites in Sri Lanka, we can look at what other people have done. We can look at how other people have solved the problem and maybe use the same pattern to solve the problem that we have to solve. For example, if you want to decide on the time to go or time to leave for this trip, what we can do is we could actually look at the times that we left for our other trips. If we have gone for other trips like Kandy or Matara or some of the other cities in Sri Lanka, what time did we leave? We can look at those time periods and maybe decide and say, okay, 8 a.m. is a good time to leave for this trip by looking at the pattern of what we have done earlier. We may not realize those are patterns that we have observed in the past and the solution patterns that we have used to solve those problems. Right? So these patterns help us to answer similar questions that we may need to answer now or today. Abstraction allows us to look at the general characteristics of the problem without going too much into details of the problem. For example, for our trip to Sigiriya, who are we going to invite for this trip? without going into the details of the specific names of people who are going to go on the trip, we can look at it from an abstract level. Is it friends that we want to invite? Is it family members or colleagues? Or right? So we can look at the problem at a higher level without going into the exact places we want to visit. We can think about the fact that we need to have other sites that we need to visit. When planning the overall trip, if we want to use abstraction, we need to look at the participants, we need to look at the cost, we need to look at the sites, right? So by looking at the list of items like this at a higher level that we need to solve, we can make it easier for ourselves to solve this problem. Abstraction helps us to solve the problem by looking at the overall problem from a higher level rather than with the minute details of the problem that we need to solve. Also, abstraction helps us to produce a common way of solving the problem and then maybe reuse it to solve other similar problems. For example, if you want to go on a trip to Matara in the south, we may be able to use the abstract level solution that we came up with for the trip to Sigiriya. Algorithm design is a way to discover step-by-step instructions on how to solve a problem. We can use the instructions to solve the problem now or later, or else we can give these set of instructions to another person to solve the same problem. For example, when we go on the trip, we will be visiting multiple sites. So what do we do at each site? Need to be decided. Coming up with the set of instructions on what we do at each site could be an algorithm design. We can also think of the overall problem of scheduling the trip as an algorithm. We plan the sites, we collect all the people going on the trip. That is an example of a sequence of things that we do one after the other. We check to see if it is raining. If it is raining, we'll have to stay in the bus the entire day, so we should take an umbrella or a cap. But if it is not raining, we don't need to take an umbrella or a cap. So we decide whether to take a cap or not based on whether it's raining or not. That is an example of a decision in an algorithm. We find a vehicle and then we start visiting the different sites that we wanted or that we decided to visit. So until we finish all the sites that we have decided to visit, we will be repeating the same thing again and again. So that's an example of repetition. We can represent this algorithm as a flowchart. We will learn more about flowcharts when we learn more about algorithm design and go further in programming. For now, think of it as a diagram that can help us to put the steps that are required to solve the problem in a diagrammatic manner. We have a sequence of steps that we do at the start of the trip. Then we have a decision that we need to make. So there's an example of a decision, and then we have to repeat something until we finish all the sites. We need to repeat and continue on the trip. So these three components, the sequence, the decision, and the repetition, are what we use in algorithm design. We may be using it in different combinations, one inside another one. That is how we can solve all the problems or most of the problems that are out there using algorithm design, or coming up with a collection of steps that can solve the problem. We can also represent the same solution using pseudocode. Pseudocode is a way of writing a solution to the problem in an informal way for us to represent how we solve that problem, and also for other people to understand how we have solved the problem. Pseudocode is not a programming language, but we can very easily convert the pseudocode representation into a programming language like Python, Java, or any other programming language. If we can think of getting machines to solve the problems by understanding the solution that we have come out with, that is what we try to do by building machines or computers to take each step at a time and solve the problem that we have by looking at the steps of the solution that we have given to the machine. Humans use tools to help them. They use tools or machines to solve their problems. The earliest use of a machine to solve problems of calculation or calculating is found in the use of abacus. That was able to do the additions, subtractions, and divisions and multiplications.
It does not matter whether the numbers are 3 and 5 or 300 and 500, the machine could help us to calculate the answer. But it was a very, very simple machine built for calculation only. The next computing machine we see in history was built by Charles Babbage, who wanted to come out with a machine where we can solve different problems that have different solutions. The difference engine is a machine that can be adjusted to the problem that we want to solve. It was possible to create a simple algorithm as a solution for a problem and use the engine to solve that problem. This was a mechanical machine that had a lot of wheels and arms, similar to what you see in a mechanical clock that works together to give us the time or the solution from this difference engine. Each time we want to solve a different problem, we had to change the settings of the machine by adjusting the wheels and how they are connected to each other to solve the problem. But still, it was better than the abacus, since it was able to solve different categories of problems other than just the basic calculations. After that, we see the use of electricity and electronics to build machines to solve our problems. ENIAC was one of the first computers that was able to solve different problems, and also we were able to give the algorithm to the machine in a much more easier manner than what it was with the mechanical machine. It was a huge machine, and there were a lot of devices and wires going all over the place, connecting the components and transferring the electrical signals all over the place. But ultimately, it was able to give the solution to the problem that we have given using an algorithm and representing that algorithm in this machine. Going further, von Neumann was able to separate the data and the instructions or the steps used to solve the problem from the engine or the processor that was actually solving the problem. This is like writing what you learn in your mathematics class on how to solve a problem in a book. And when you are given a problem to solve, you look at the book on the steps of how to solve that problem, take the question that is given by your teacher and solve the problem. Now, using computers, we can solve different problems with different data because we have been able to separate the data and the instructions and the engine or the thing that is actually solving the problem for us. We have computers that have separate memory to keep the data and the instructions to solve it in a separate processing unit that can take the instructions and the data and the corresponding data and give us the solution. Memory unit is like a large box where we can put all the data we want to process and also the instructions on how to solve the problem. The processing unit will take one step or one instruction at a time and also the corresponding data and process it and do the calculation and produce the result for us. Based on von Neumann's idea, we can look at the modern computer. We have a memory unit and a processing unit. Processing unit has a control unit that keeps track of the overall operations, kind of a manager of the system, and an arithmetic and logic unit that can process the instructions given to it. The memory unit has the data and the instructions. We also can connect input devices such as keyboards and thumb drives to give instructions and the data to the main unit. And we can also have output devices such as computer screens and printers to show the solution that is produced by the computing unit, the solution that is produced for the problem that we are trying to solve. If you look at a summary of what we have covered in this session, we looked at computational thinking by looking at an example of solving a problem of going on a trip. We looked at how we can decompose the problem and break it into smaller pieces so that we can solve each part separately. Then we looked at the pattern recognition to find similar patterns in problems and their solutions and then reusing the similar solutions. Then we looked at abstraction to look at a problem from a distance so that we can get away from the minute details of the problem and solve it. Also, we looked at algorithms to come out with step-by-step instructions on how to solve a problem and maybe tell someone else to solve the same problem. We also very briefly look at how historically we have used computers and computing machines to solve our problems. We also look at the different parts of a computer at a very, very high level so that we know how they are connected and how it is solving problems, or how it is getting the solution to the problem and then solving the problem for us. Now that we know about computational thinking and how to solve problems using computational thinking, we need to know how we can write the solution to the problem using a language that the computer can understand. I can tell you how to go to Sigiriya in English or Sinhala or Tamil. Similar to that, we need a programming language such as Python to communicate with the computer and tell how to solve the problem. That is what we are going to learn in Python programming. Let's meet with another session on how to solve problems using computers by writing code in Python.